Hey there, my name is Jonathan. Today I'm gonna show you how we can create a scalable and maintainable codebase architecture using different tools like NX, Prettier, Eslint, and Typescript. What we are going to do during this video is set up a sample real-life codebase where we are going to host three different applications. A Node.js API called Random API, which exposes an endpoint that returns back some random data, and two different React applications, App1 and App2. Both these apps will share some common piece of functionalities like UI components in case of the two React application, and also a common API interface to interact with the random API. All these common functionality are going to be extracted into proper libraries that will live under the libs folder. The main tool we are gonna use to create, set up, and maintain this code base is called NX. NX is a modular build system for architecting, scaffolding, and maintaining large code base, and it uses the monorepo pattern. A monorepo basically is a single repository that hosts all of our application, libraries, configuration, custom tools, etc., all in a single place. And this is the opposite of another common pattern, which is the multi-repo pattern, that instead use separate repository for each project we create. There are multiple benefits of using a monorepo pattern, and the most important one are code sharing, having a single set of dependencies, enforcing coding standard, and much more. We are going to discover all of them throughout this video. Okay then, enough talking for now, so let's get into it. Okay, so let's start by creating our workspace, and for doing that, we are gonna use NX workspace. So let's run yarn create nx-workspace, and we also need to specify the package manager. So -- package manager. We are gonna use yarn. Okay, let me increase this terminal. So it asks us how we want to name this workspace, and I choose to use NX Playground for this tutorial. Then it asks us which stack do we want to use. We are gonna to select none. Then it asks if we want a package-based monorepo or an integrated monorepo. We are gonna use an integrated monorepo because we are going to store both our application and library in the same repository. And finally, it asks for if we want to enable distributed caching, but we don't want it for this tutorial. So let's set none. And now is installing the dependency. So let's wait for the dependency to be installed, and then we will get back to work. Okay, so our workspace has been created. So let's open it up with Visual Studio Code. So let's run code nx-playground. And this is our initial code base. You can see we don't have so many files, and that is perfect because we are going to add all the configuration file one by one, and I'm also going to explain each file that we are going to add. Okay, so let's take a look at the file that was generated by NX workspace. So you can see that NX generates some initial file, obviously the yarn lock, since we are using yarn as our package manager. We have our package.json that specifies the name of this workspace, which is @nx-playground. And this will be super important because this @nx-playground will be used every time we are going to import a specific library throughout our project. So we are gonna see that we are going to reuse this string right here. We specify the version, a license set to MIT. We don't have any script for now. And we can see that we are also specifying some dependencies that are only inside the dev dependencies. And you can see that we only add NX, the NX workspace plugin, and also NX/JS, which is a plugin for generating TypeScript or JavaScript project. Okay, so what is actually missing right now inside this package.json is specifying a package manager. So let's go ahead and let's type package manager and let's specify yarn, and we are gonna use version 1.22.19. Also here we have to specify a comma. And as you can see, this defines which package manager is expected to be used when working on the current project. And this is super important also for other people that are going to work on this workspace. So they will use the same version of Yarn that basically we use for scaffolding this project initially. Great, so that was it for our package.json. Another important file is nx.json. So basically this file is a global configuration for our NX workspace. As you can see, it's pretty empty right now. The only thing that we are defining are these target defaults. So basically target defaults are some configuration regarding some target script. For example, here we are specifying that for every target script that are going to run the build command, we want this to be cacheable. And you can see that it also specifies that it depends on other build. So for example, if we have two projects that depends on each other and we want to build one of these projects, this will tell NX that we must first build the project that it depends on before building the final one. As you can see here, we are also saying that all the linting script can also be cacheable. So if we run it multiple times and we don't change anything, basically we are going to cache the results, so the development experience will be super fast. Here, instead, we define some named inputs that are not super important right now to understand. So let's go ahead and let's see some other files. Okay, we have yarn rc, which is an auto-generated file. We have a git ignore, so you can see that basically this workspace has already been initialized with a git repository. You can see that we have already the main branch. And we have also an editor configuration, which are basically are going to extend with Prettier later on. Okay, then finally we have the VS Code folder to specify some extension or settings that we want to apply to all the devs that are going to use VS Code to work in this workspace. And finally, we have a .nx folder. This is where NX store is a cached result, for example, command like build, linting, and so on. So that's it. So great. So what we are going to do now is creating two folders. The first one will be the apps folder, and the second one will be the libs folder. So inside the apps folder, we are going to store all of our application, like for example, our Node.js API and the two React application. While inside the libs folder, we are going to store all the libraries that are going to hold, for example, all the common functionality that are going to be shared between our application, for example, our UI components, our API interfaces, and so on. So now we have to tell NX to treat these two folders as an application folder and a libraries folder. So let's go ahead and let's open up nx.json. And here, let's add a new property called workspace layout. And here we are going to specify first the property apps directory, which are going to be apps. And then we are going to specify the libs directory, which are going to be our libs folder. Awesome. Okay, the second step will be adding a file called .mvm.rc. So inside this file, we are going to specify the version of Node.js that we are going to use throughout this code base. So this version will be locked and will be used for all of our projects that are going to run Node as a base running environment. So for this project, I decided to use the version 18.19.0, which is also an LTS version of Node.js, so should be pretty safe to use. Awesome. And generally, after having set up the Node.js version, what developers should do is open up the terminal and run first nvm install to basically install this version of Node.js. As you can see, it say now we are using Node v18.19. After having that installed, we need to use it. And for doing that, we are going to run nvm use. And so basically I was already using that version, so the output is the same. Awesome. Okay, so as we were seeing before, we are gonna use Typescript for managing the most of our project, even though generally this monorepo architecture can also handle multiple programming languages. But for the sake of this video, we are only using Typescript. We are gonna specifying a file called yesconfig.base.json. And this file will hold our base configuration of Typescript that are going to be used by all of our project, and it will be also possible to extend it if we need it in other particular project. So, okay, so let's define our base configuration. Here we have to specify an object, and the first property that we are going to specify is compile on save, where we are going to set false. So compile on save basically enable the compile on save for this project, but we don't want this feature be enabled. So let's go ahead and let's define some compiler option. Okay, the first compiler option is the base.ur, which will be the current directory. Also, we have to specify the root directory, which is also the current directory. Then we are gonna specify the declaration and set it to false. So declaration basically it's whether or not we want to generate the .d.ts files from TypeScript and JavaScript file in our project, but we don't want it. Okay, then we have to specify a module, and we are going to use next. So let's go ahead and let's also define a module resolution, and we are going to use node. Great. So let's define a target. So the target will be ES 2015. We also want to skip the default lib check, set it to true, and also skip the lib check and set it to true. So these two property basically is for skipping the type checking of .d.ts files that are included with TypeScript. And here basically we are skipping the type checking of all the .ts files, including the one inside the node modules. Another useful property will be module interoperability, having that enabled. So this is for emitting additional JavaScript to ease the support for importing common JS module. Then we are going to specify some library that we want to be referenced without an explicit import. In this case, we want the library next. Then we want the DOM library and also DOM.iterable. These two are mainly used for having React working correctly. Then we are also going to specify some import helpers, set it to true. This basically allow importing helper function from tslib once per project instead of including them per file. Then we are going to allow synthetic default imports, and also we are going to resolve also JSON module to basically have the possibility to import JSON inside our TypeScript files. So let's go ahead and let's add also the strict rule. So this will enable all strict type checking option. And yeah, so that's it. So this will be all the option that we are gonna use for all of our TypeScript project and application. And one piece that we are missing is to exclude the node modules. So yeah, this is our TypeScript based configuration, and now we can move on. Okay, our next step will be now setting up Prettier for having a consistent file formatting throughout all of our project and libraries. So let's open up our terminal, let's clear it out, and let's run yard add -d Prettier. Great. So Prettier basically work with two configuration files. The first is the .prettier.rc, and the second one will be Prettier ignore. So inside the Prettier RC, we are going to specify some rules to apply when we are going to format our files. So let's define our configuration. So the first property will be the single quote property that we are gonna set it to true. So the single quote basically it just say to use single quotes instead of double quotes, and that's pretty straightforward. Then we are going to use the semi and set it to false. This basically will avoid to print the semicolon after the end of each, for example, property definition or whatever a semicolon might be needed. Then we are gonna to specify a bracket spacing and we are gonna set it to true. So bracket spacing basically prints spaces between brackets, and this is super useful in case we are using some, for example, inline style inside our React components. Then we are going to specify a trailing comma set to whole. So basically this will append a comma after wherever it's possible, including, for example, function arguments. Then we are going to specify a print width set to 100. We're going to use a tab width set to 2. We are going to set use tab to true to have tabs instead of spacing. And finally, we are going to add end of line set to LF, which stands to line feed, or basically to append a \n after the end of our lines. Great, so this is our Prettier configuration. Now let's set up our Prettier ignore. And so here we are going to define all the files that should not be formatted by Prettier. In this case, we are gonna add just this folder, the coverage folder, and the .nx/cache. And I also think that we can include the node modules here. Awesome. Okay, obviously this Prettier configuration is fine, but I think it's not working right now. And that is because we want to format our file when we perform some action, for example, when we hit save. Or another way, for example, is to open up a terminal and running npx prettier --write and specify the current directory. And this basically will format all of our files basically. And you can see that I think that has applied some formatting to our rts-config.base.json. Okay, so running a script is fine, but most of the time we want to formatting our file every time we hit save, especially if we are using, for example, VS Code. So you can see that here we have a folder called VS Code. So if we go here, we can specify a new file called settings.json. And here we can specify some configuration for our VS Code editor, and also this configuration will apply to other developers that are going to use VS Code to work on these workspaces. So let's define this settings.json. The first thing that we are going to specify is the editor.default formatter, and here we are going to use ESVNP Prettier VS Code. So basically it's uses a default formatter Prettier. Then we are going to apply one super important property that is going to be editor format on save and set it to true. So every time we hit save, the current file will be formatted. Then we are going to specify some code action on save. So code action on save. And here we are going to say that we want first organize the imports. So if we have multiple imports, when we hit save, we want them to be organized, for example, alphabetically. And we want also to fix all possible errors that might be present in that file. For example, error related to Typescript or error related to ESLint. And finally, another important property could be the word wrap. Let's set it to on. So this will be basically wrap our lines if they overflow the current viewport width. That's it for our setting.json. I want to show that it should work correctly. So for example, if I open up tsconfig.base.json, and I go here, for example, and add some spacing, you can see that every time I save the file, it gets formatted automatically. For example, if I go here and remove this comma, okay, now this is an explicit error, but you can see that it's working, you know. If I add some spacing, I'd save, it's working. Awesome. Okay, I think that we are now ready for adding our first application. And for starting off, we are going to create a simple React application that we are going to name app1. To generate this React application, we are going to use an NX plugin generator, which are going to scaffold our React project for us. So let's install this plugin. So yarn add -d at nx/react. Now what we can do is run nx generate, or actually we can also say nxg. And so we specify the plugin, so nx/react app, that stands for application. We are gonna pass a name, which is gonna be app1. We are gonna also specify a directory, which is going to be apps/app1. Then we are gonna also specify the property minimal, set it to true to have a minimal installation of this React application. And finally, we are also gonna set Pascal case files, set it to true. And this to have all the files to having a Pascal case format. So let's run it. And it asks us which style sheet format we would like to use. I'm not going to use any specific style sheet for this project. We're gonna use just some inline CSS. And now it asks if we would like to add React router. We don't want it. It asks if we want some kind of end-to-end test. Nope. And which bundler do we want to use? Vite is fine, since it's pretty simple to configure also. Finally, what should be the project name and where it should be generated? We can say as provided. Let's wait for all the dependencies being installed, and then we should see our app1 application inside the apps folder. Awesome, the installation has finished, and we can see that under the apps folder, we have the app1 folder, which holds our React application. So you can see that we have a source folder with an internal app directory, with an app.tsx file, and this is a simple auto-generated component. You can see that here the formatting is pretty messed up, so if we hit save, you can see that Prettier is working fine. Also here this stuff is not necessary, so we can remove it. And so yeah, we have an asset folder with any file inside. We have a main.tsx. This is the configuration needed for launching React. And you can see that we have an index.html where we link the main.tsx file. This is basically pretty common configuration using by Vite for scaffolding a new React application. But most importantly, I want to focus on this configuration file right here. You can see that we have 3 different Typescript configuration. The first one is the tsconfig.json. So let's open it up and let's also format it. You can see that this configuration specifies some internal compiler option, but basically you can see that it extends automatically the tsconfig.base.json that we previously defined. So basically what it's doing is taking this tsconfig base that we defined before and then extending with some custom configuration. For example, we are saying that we do not allow for having JavaScript file. These one are duplicated since are already set as default by our TypeScript base.json. It also references 2 other TypeScript configuration, tsconfig.app, which basically specify what file should be compiled by the TypeScript compiler. In this case, we are saying all the JavaScript, TSX, TS, and TSX file. And we're actually excluding all the files with the .test or .spec file. This will be super important to not bringing this stuff in our final build for this React application. We are also specifying the output directory. We're specifying some base types to use. We have also this vite.config.ts. This is for setup Vite and how to launch this React application. For example, we are saying to launch the server on port 4200, launching the preview on port 4300, using the host as localhost. And also we are specifying some related file to the build directory. We are specifying some stuff regarding the testing environment and so on. So I will not focus so much on this configuration file because this is pretty specific to the Vite setup. Okay, so at this point, I can show you that we can launch this application using the nx CLI and say nx run app1 serve. And you can see that this application is listening on port 4200. So let's go here and let's type local host 4200. And here our React application that is working perfect. You were wondering, hey, where did you take this script right here? So basically this script is defined inside this project.json. You can see that internally, along with other configuration file for this NX project, like his name, his source root, his project type, we have these targets. These targets basically contain some script that can be run on this React application. For example, we have a script specific to build this React application using Vite. We have the serve script that is the one that I used for running this application in development mode. And you can see that it has basically inside the configuration property, we are saying that we want the hot module replacement to be true. And we have also another configuration for the production build in case we want to launch this application in production mode. We have another script for running this application in preview mode. We have another script for running test. We have a script for linting all the files inside this folder. So here we can add also some custom script. For example, let's say that we want to run a type check for all of our files. So we can go here and define the script type check that is going to take this configuration. So basically we want to run a command. We are going to use the tsc command and specifying the project is going to be under the apps folder. Project will be app1. We want to use the configuration file specified in the tsconfig.app.json. So here we are going to say tsconfig.app.json. And that's it. So what we can do right now, open up a new terminal and run nx run app1 type check. This basically will run a type check for all of the Typescript file that we have inside this project. And this, believe me, will be super useful, especially in very large projects. We can also add another script, which will be format code. And here we are going to specify another command, which is basically just running Prettier to format all the files that we have inside the app1 project. So the command will be this one. So we are going to run Prettier under the apps /app1 and including all the file that have this file extension. So JS, JSON, TS, and TSX. So let's test this out. So I can go here and say nx run app1 format code. And this, you can see how it will format all of my files that have the extension that I specified there. Awesome. Another important thing that I want you to notice, because it's super important, is that this React application, app1, has no kind of package.json. So you might be wondering, wait, where is the file where this application specifies all of these dependencies? Well, you must know that an NX repository is managed by using a single version policy. So all of the dependencies will be added inside this root package JSON. For example, here we have some dependencies, and also here we have some dev dependencies. But this is super important because having a single package.json will mean that every project or libraries that we have will use the exact same version of a specific dependencies. This is super important because in this way NX resolves the issue of having, multiple package.json. Awesome. And finally, another important thing that I want you to know is that inside app 1, there is no node modules. So all the node modules are specified inside these root node modules. And this trick is called deduplication. So in this way, having a single node module will prevent us to having multiple node modules that can increase the overall size of our entire code base. Awesome. Okay, another file that has been generated is this eslint.rc.json. So basically, ESLint is a tool for enforcing coding standards throughout the code base, throughout project. And here you can say that app1 has an internal eslint.rc.json that is referencing a root eslint.rc.json that previously we didn't specify. So you can see that NX in this case has generated for us an initial configuration for ESLint that now we are going to extend this ESLint configuration to enforce some kind of coding standards, for example, for React hooks, follow certain coding style, and so on. So this is the one generated by NX. You can see that has already set the property root has already been set to true. That means that this is the parent root configuration. Here you can say that inside override specify what files should ESLint go looking for in order to be linted. In this case, we only specify TypeScript and JavaScript files since we are mainly use these programming languages. And also specify an initial rule, which is the enforce module boundaries. So enforce module boundaries is basically an internal pattern used by NX, which is super useful as the word suggests, specify boundary between application and libraries. For example, you don't want that a library A depends on a library B, and so you can specify that boundary right here. So in this video, we are not going to specify any kind of boundary. But I encourage you to read the documentation for this rule because it's super, super important, and in very large company and code base is always used. So what we are going to do right now is applying some coding standards that we are going to install by external dependencies. So what I'm going to do is first clearing the console and adding two dependencies. So let's run yarn add-d. The first dependency will be eslint-config-airbnb. And then we are going to also import eslint-plugin-import. Okay, so I made a mistake here. This should be Airbnb. Awesome, now it should work. Okay, once these plugins are installed, what we are going to do is adding a new property here called extend. And here we are going to specify some ESLint configuration that we are gonna take from this plugin that we installed. For example, here we are gonna add Airbnb and also Airbnb/hooks. Basically, this Airbnb is referring some coding standard that Airbnb has set up internally and is a super useful, guide to use. Is a coding style that is very, very popular. I think it's fine to use it for our code base. As you can see, it specifies some rules and standards to use for any kind of scenario like types or naming convention, typecasting, variable, hoisting modules, and whatever you want. So I think it's fine to use Airbnb hooks, but we are also going to use some other ESLint configuration like plugin, import Typescript. This basically will apply some rules to our importing statement that we are going to use throughout our files. We are also going to use plugin, React, and we're gonna take recommended. And also we are gonna take, let me go in a new line, plugin, React hooks / recommended. Awesome. And finally, we are also gonna inherit some rules used by Prettier. So if you recall, inside app 1, inside project.json, we have this lint script that is going to run eslint to obviously lint our application. So we can go here and run nx run app1 lint. And you can see that we are having some problem. That means that there are some files that are not following the coding standard that we specified inside our eslint configuration. For example, this one. So here we are inside the vit.config.ts, and you can see that say vit should be listed in the project dependencies, not dev dependencies. I guess that if you open up also app.tsx, it say React must be in scope when using JSX, React must be in scope, etc. So the problem with this error, I mean, they are fine, but the standards enforced by these plugins that we defined are a little bit too strict for this project. So what we can do is going inside the rules property and decide to turn off some of these too strict rules. For example, we are gonna turn off React in JSX scope, and this will avoid the necessary to import React from React. And as you can see, some error has already disappeared. So let's add some other rules that I already prepared. We have this one. Okay, this one is to allow JSX syntax in TSX file. And so you can see that now we don't get those errors that we were seeing before that were given basically by these two rules that, in my opinion, were a little bit too strict. But I think that we can add some other rule. For example, here we can add rules of hooks. In this case, we won't say that if we violate some of the principle of the correct usage of hooks, we want to throw an error. And this is super important. Let's take it another one, which will be no name as default. This will allow only named export with any specific default export. We have some other one, mainly related to the import, this 4 line right here. And this is for example, this is to turn off some weird error when you import like this one that you're seeing right now is an eslint error given by some of the rules defined inside this plugin. So this is a good configuration, but still we have some problem, and it says that Vit should be listed in the project dependencies, not as a dev dependencies, and also for the Vit.js plugin React. So for fixing this error, we can go inside the package.json and take Vit and move it from here to here, and also we are gonna search for Vit React, and this one we are gonna paste it here, and now this error should disappear. Actually, another trick will be when you get some error that don't disappear even though you fix them, maybe you need to relaunch the eslint server. So let's reload the eslint server. Now it's saying nxvit should be listed in dev dependency, so this one must be defined here. So reload eslint server, and you can see that the error has disappeared. Awesome. So now we have our eslint configuration working properly, And with this configuration, we will be assured that some coding standard will be followed throughout all of our project and libraries. And so other developers will know when they will make an error that should not be expected to be there. So yeah, this is another important step to build a very scalable and maintainable code base. Great. Okay, at this point, what I want to do, if you recall from before, we have inside this terminal, we have our app1 working properly. So let's rename this terminal to app1. And okay, let's see if it's still working. Let's close this tab. Yeah, it's still working. So let's add some styling to this application. So let's add the app.tsx. Let's go inside the div. And as I was saying before, I'm going to use only inline styling. So let's set display set to flex direction set to column, also align items set to center. Great, this should be center our welcome string. And let's also make this part like, let's color this up1. So let's remove it, let's move it here, and let's go here and set it as style with color set to red. Awesome. And it's working fine. Great. So another thing that I want to show that after having applying our ESLint configuration, now if we run up1 lint, obviously all the files will pass the linting check. And so we know that this project is looking fine. Awesome. Another thing that I want you to know is that for generating a project, you can also use the NX console, where you can run different scripts. For example, a task for generating a project, target for running a project, etc. And here you should have listed all the projects that you have right now, and you can also launch some of the target script that project has specified internally. So you can see we have our type checked, our format code, our linting script. And the NX console is super useful to not have every time launching our script just from the command line. Okay, so with that being said, let's create another application, which we are going to name app2. Actually, we are going to use nx generate at nx react column app, and we are gonna name it app2. We are gonna specify a directory, which is going to be under apps folder, by the app2 directory. We also specify a minimal installation, so minimal set to true. And finally, Pascal case files, that also to true. Okay. We would like React rather no. We don't want any end-to-end test. This will be as provided. Inside our apps folder, along with our app1, we have our app2, which is basically the same. And okay, so we have some stuff that we don't need. You can see that this file and also other files are not formatted nicely. For example, even this eslint.c.json. What we can do is just copy these two target script that we used for the app1 and paste it inside this project.json, because we are gonna use it also for here. And here, obviously, we have to specify up2. And also here, we have to specify up2. Great. So now, if I go here, so let's run nx run up2 format code. You can see that all of my files should have been formatted. Main.tsx, project.json. Let's close this tab. Yes, config, also the eslint. Okay, the app.tsx is not being formatted because it was open, so Prettier does not take the permission to try to format a file that have some pending changes. So this will be formatted by us. So it's looking fine. And this will be our app2. So if we want to launch this application, we need to remember that inside the Vite configuration, we should update the port, because otherwise we'll collide with our app1. So let's set, for example, 5,200 here, and for the preview 5,300. And so we can go here and launch our up2. So nx run up2 column serve. And you can see that it's listening at port 5200. So let's rename this terminal as up2 to remember that this is the up2 and this is the up1. Now, if we go here and type 5200, you can see that we have hello there, welcome up2. Okay, once we have our up1 and up2 working fine, we can start creating our first library. So I want to show you the power of having a monorepo managed by NX in this case. And what I'm going to do now is under the lib folder, defining a component that will be used both by up1 and up2. And I'm going to show you also that every time we change this component, all the changes will be reflected respectively in the up1 and up2. So basically what we are going to do now, under the libs folder, I'm going to create a new folder called UI. And inside this folder UI, I'm going to create another folder called components. Basically what we want to do is to create a library specific for this component. So let's go here and let's open up a new terminal and let's run nx generate at nx /react. This case will not be an application, but will be a library. And we're gonna name this component timer. So here I'm going to specify UI timer, and we need to specify a directory, which is going to be libs /UI /components /timer. And we want a minimal installation, so minimal set to true. We don't want any component be installed, so component set to false. And finally, we want Pascal case file set to true. Let's run it. So what unit test runner should be used? We don't want any unit test runner for this component. Which bundler we want to use? We don't want any bundler. And this will be as provided. Awesome. So let's see what is happening. Let me just maximize this. Okay, you can see that the timer project folder has been generated. Inside this folder, we have a source folder with an index.ts. And here basically is where we are going to export our component. We have also an Eslint configuration that is not formatted. We have a Typescript configuration, which obviously, as always, will extend the root configuration, that tsconfig.base.json. We have a lib.json, tsconfig lib.json. Okay, so let's go here. Let's define our timer component. So let's define our timer.tsx. Okay, so timer component basically will just display the current time using a very simple format. So what we are going to do here is using a useState, which will hold the current time in milliseconds. So here we are going to have set time ms. Here we're going to use the useState, and this obviously will be a number, and by default will be set to day.now. Awesome. And basically we just want to render this time like that, span, and here just take time ms. But obviously this must be updated every second. So for doing that, we're gonna have a use effect. Basically what we are going to do here is starting an interval that will run every second. So let's define an interval. So const interval equals to set interval. And here we need to specify the callback function that must be run every, in this case, every 1000 millisecond, which basically is 1 second. And here we are gonna set time ms to date.now. So basically what is happening here is that every second we are going to update this time ms with the current times in millisecond. And also it's super important here to define a cleanup function. So here we are going to do clear interval and we will pass interval. So, okay, what we can do now is go inside the index.ts and export everything from this timer component. Here we are getting an error that says no named export found in modules timer. Yeah, I think that the reason for that is that we need to remove this and say export function timer. Okay, so yeah, it works. So we have to specify this like as a named export and not as a default export. Okay, now let's use this timer component in both app1 and app2. So let's open up app1, source app.tsx, and let's go here and let's add this timer component that we can just add in this way. Here you can see how simple it was to just add this timer component, and we actually import that from NX Playground and the path UI timer. So you might be wondering, wait, where did you define this path right here? So basically every time we create a new library, NX will update our TypeScript configuration, and under the paths property, which specify all the path aliases, you can see that how it just added the NX playground UI timer, which basically referenced the component, or better, the index.ts file of the library that we have just created. And this will be applied for every library that we are going to create in this code base. And this allows us to have this nice and clean import, which it just works. In fact, if now I go back to my application and go to app1, okay, so I think that we need to restart our app1, otherwise it will not work. So let's run it again. And you can see our timer is just working, even though it's not like rendered in a very proper format. But what I want to show you is that we can go inside our app2, open up our app.tsx and do the exact same thing. So reusing the timer component just right here and importing with the corresponding path. So here we basically did the exact same thing. I think we need to restart the app2. So let's clear this out and let's run app2. Okay, so if we go back to app2, you can see that our timer is here. So what I want to show you is that now every time I apply a change to this timer component, the result will be immediately visible throughout all the applications that are basically reusing this component. For example, let's add a simple time formatter. So let's go here and let's define this time formatter. This is basically using the int date time format, which basically will take in input this time ms and will format in a proper way. So what we can do right now is going here, and instead of rendering the current milliseconds, we can say time formatter dot format time ms. Great. So now if we go back to our application, you can see that how the time is formatted in a proper way. Even if I go in the app one, you can see that is very, very cool. Now we can also add, for example, I don't know, some styling. Let me just paste some styling that I already created. So I can go here and specify this style, which is called time. So now this CSS should be applied, and you can see how it's working both for app 2 and for app 1. Obviously, we can also do other thing. Every time we make some breaking changes to this timer component, this will break all the application that needs to be, updated according to the changes introduced. So let's say, for example, that I go here and decide that I want this component to take a prop as input, and this prop will be the color prop, which will be a string. Awesome. And now you can see that app2 and also app 1, Typescript recognizes that some breaking changes has been introduced. And if we go here, we obviously must specify the prop color. So for example, here I want red. Here I want, I don't know, green. And let's just use this color prop here. Color. Awesome. And you can see that now app 1 rendered this time as red and this one in the app 2 as green. Awesome. This is the power of having a monorepo. Like every time you change a library, you have this experience that if you introduce breaking changes, you need to apply the proper update. And obviously, it's super simple to switch between tabs, looking at the implementation of the files. It's an experience that with the multi-repository approach is not even possible. And also, you avoid, having duplicate code, etc. Okay guys, now what I want to show you is that another cool functionality of NX, which is called, if I go here, clear this terminal, is called NX run many, which allows to run a single target script for multiple projects. For example, let's say that I want to run the type checked for the app 1 and app 2, and also for the timer component that we have just created. So what I have to do is go here and run nx run many -t, that stands for target, and say the target that I want to run, in this case type check. You can see that we have run the type check script both for app 1 and for app 2, but not for the timer component. And that is because the project.json of the timer component does not have that target script defined, but it only has the lint script. So let's go here and let's add the two missing script. I'm just copying this out because we have already seen how they work. So what we can do here is running the same command. And you can see that we have running a type check for app 1, app 2, and UI timer. We also can run a different script, for example, the linting script. This will lint all of our files. And for example, here we are getting an error from the app 1, which say that the next fit should be listed in the project dependencies, but actually should be already hit. So I think that this must go here, like that. And if we restart this lint server, now it works. So yeah, let's see if that fixes our issue. Let's run the linting for all of our project. And you can see that the UI timer lint, it's a existing outputs match the cache, and it was left as is. And this is another cool functionality of NX. It is the possibility of caching some of these target runs in order to increase the development experience. For example, for app 1 and app 2, we run the lint from scratch, but not for UI timer because we don't change basically anything. So if I go here and running this run many again, all of the three tags will be cached, so we will get back immediately the result, because basically we didn't change anything, so there is no need to rerun it completely from scratch. And this is super useful, for example, when also we are going to build our application. Let's say that I'm going to build app 1 and app 2. I can run, for example, I don't know, maybe nx run app 1 build, and this will create a build production for our app 1 that will be stored inside this folder. You can see that it's been here, but if I run it again, it will be immediately cached because we didn't change anything. And this is another cool functionality that NX provided, and is super useful in very large projects such as very large code base. Finally, NX CLI provide another tool called NX Graph that I'm going to run, and is basically this kind of client interface where if we go here, let me just zoom in a bit, and we click on show all project, this is the final result. Basically, it says that we have two apps, the app 1 and app 2, and both depend on the UI timer component. This is super important to analyze our workspace and to understand what are the most used library, or what are some possible bottlenecks that currently have in our code base. It's a super useful tool for analyzing all the dependencies that we have in our code base. Great. I think it's time to spice the things a little bit, and I'm going to add a third application beside app 1 and app 2, but this time we are not going to create a React application, but instead we are going to create a Node.js API server. So let's start by adding the custom plugin generator. So yarn add -d, it will come always from NX, and we are going to use Express since it's one of the popular way to create a Node.js server. So let's install the plugin generator. Awesome, the plugin has been installed. And now let's generate the project. So nx generate at nx/express : this is an application, so it will be suffixed with the app string. I'm gonna name this API random API because we are going to expose a single endpoint which will return back some random data. We need to specify a directory which will be under the apps folder, and the name is always random API. Then we need to specify some other option like skip package JSON set to true. And also we don't have any kind of test runner, so unit test runner set to none. Okay, that should be it. So let's run this generator. We can choose as provided, and now it's going to install the dependencies and will scaffold our Express application completely automatically. Okay, the Express application should have been scaffolded. So you can see that under the apps folder, now we have random API and also a fourth application, which is random API end-to-end. This is a separate application for running our end-to-end test, but we don't need it for the purpose of this video, so we can safely remove. So yeah, let's go get a look at this random API. Okay, you can see that it's using Webpack as bundler, which is different compared, for example, to app 1 and app 2 that were using Vite. And okay, under the source folder, we have this main.ts, which already has set up for us an initial sample of Node.js API. For example, you can see that here we are exposing at the root/API. We are listening for get request, and we are responding back with this message that say welcome to random API. Okay, so we can remove this comment. Here we have some problem. Okay, let's try to restart eslint. Sometimes it happens that eslint throw some unexpected error, so my advice is to always to run restart eslint server or restart also Typescript server. Okay, so basically this is initial configuration. You can see that the server will be listed on process.env.port, but since we don't have that defined, will be listed on port 3333. Okay, I think that we can leave it as is. So let's remove this, and let's also rename this route, and let's name it, for example, API/random. And here, what we are going to do is to first get a probability by running math.random. This will return a random number between 0 and 1. And so here I'm going to say const color. If the probability is less than 0.3, we are going to return red. Otherwise, if the probability is less than 0.6, but obviously greater than 0.3, we are going to return blue. Otherwise, the default case is, I don't know, green, for example. Awesome. Obviously, we have to return this value. Actually, we don't need a return. We can just say return.status 200 and say return this JSON with our color inside. Okay, here say do not nest ternary expression. This comes from eslint rule, but this is fine for this line, so I'm going to disable the no nested ternary just for this line. Awesome. So what we can do now is try to run this application. nx run random dash API colon serve. Okay, let's see what happened. Okay, it seems that it works. So you can see that it's listening at HTTP localhost 333/API, and these are just some debugger. They are not really errors. So what we can do for testing this API is using the Thunder client. And actually here I have already prepared a call to this API. So you can see that here we are making a GET request to the localhost, the port of the server, API random. Actually, we don't need this color here. So yeah, let's try it. So let's try to send a request and we get back this response, which is color blue. If I send another request, we get a red, another red, a green, red. Okay, it's working fine. Okay, before moving in, let's just go back to the random API. Let's go into the project.json, and here, as we did for the other project, we are going to add the type checked and format code target script, which I'm going to paste here. So now what I can do is open up a new terminal and, for example, say nx run. Let me minimize this a bit. Nx run random API format code, which will format all of my file. And we can also do a type check and it will work as expected. Nice. Let's close this tab since this is working fine. Now what we want to do is try to generally every API expose like a common interface called API interface, which is public. And so it will be somehow shared between the API itself and the other client that wants to reach this API server. So what we can do is extracting a separate library where we expose the route where this random API is listening for his request, and also the kind of response that it will return. For example, here we are returning a JSON with a property called color, which is a string. So we want this data be available for the project that wants to reach out for this API. So if you guess correctly, the way that we are going to do this is extracting a library for that. And inside the libs folder, I'm going to create another group folder, which I'm going to create API interfaces. Actually, let's close this tab. We created API interfaces. And inside these API interfaces, we are going to create just a TypeScript library that will expose some of these interfaces related to our random API. So what we can do now, first we know that this terminal is the random API. So let's rename it and let's get to our terminal. Now I'm going to run nx generate at nx because we are going to use the plugin JS for generating a library. We have to specify that this is going to be a library. We're going to use the name is going to be random-api-interface. Let's set the directory to be under libs API interfaces and then random-api. Let's set up a minimal installation, so minimal set to true. Then we want to specify the unit test runner set to none. And finally, we also have to specify this option called project name and the root format set to as provided to avoid encountering some weird error. So now it asks which bundler do we want to use. We don't want any bundler. And yeah, it should have been created. So there it is, our random API interface. We have the index.ts, we have a lib folder, but actually for this video, we are going to export just very few things. So this lib folder can be removed. As you can see here, we have the tsconfig with this custom option. We have the tsconfig lib. And okay, so what we are going to do now is open up the index.ts. And here we are going first to specify interface, so import interface, and we're gonna name this random color API response to be equal to the property color equal to just a string. And actually we don't need this. And also we are going to export a constant called random color API route, which is going to hold for the API route for the random color function. So we say that it was API slash random. Okay, now we can start using this interface and this constant starting from our Node.js API. So let's go in the source folder, main, and here, for example, instead of using this fixed string, we can just use random color API route. Okay, so here I think we have to restart the TypeScript server. Okay, it's working. So you can see that we are importing this random color API route from our workspace and from the library random API interface. Awesome. And so now every time we change this constant here, the change will be propagated automatically here. Also, we want to just make sure that the response that we are returning back is following this kind of interface. So we want the TypeScript help us with IntelliSense and provide us with some feedback. So here in the response, what we can do is to declare response from express and then pass random color API response. So what happened now is that inside this JSON, if I remove this color and I activate IntelliSense, you can see that I have full type safety support. And obviously this must be a string, so I cannot pass a number, for example. But obviously this not work because color is already a string, so it's fine. Now every time we change this random color API response, we will have full type safety support for possible change to make to this API route. Awesome. Now what we want to do is to test that everything is working as expected. So let's rerun our random API. So next run random API serve. Okay, so let's go back to Thunder client. And now let's try to... Okay, so we are getting some kind of error. And I guess that is due to this random color API route. I think that it must include a forward slash. Okay, so let's try it again. Okay, now it's working. Awesome. Okay, at this point, our Node.js API is working fine. I think that the only thing that we are missing right now, we have to manipulate the course option. So a fast way to do this is just paste this code that I already have. So basically the Express server now will always have this header, which is going to set access control allow origin from everyone. So everyone will be able to fetch from these API servers without incurring into some kind of weird course error. Awesome. So our Node.js API is ready and we can move on. Okay, so at this point, what we are going to do is to create an hook that is going to make GET request to this endpoint to fetch a random color. And we are going to use this new hook inside either app1 or app2 to see that everything is working as expected and to highlight, this data access layer that we are going to support. So let's move on. And first, let's close this tab. Okay, before doing that, what we need to do is go inside the libs folder, and under the UI, we are going to create a new folder called hooks. So basically now, under the UI, we have components and we have hooks. And it makes sense to have it under UI because hooks obviously can only be used in a React environment. So now we can create this hook by running nx generate at nx/react. This will be a library, so lib name is going to be use random color hook. The directory will be under libs y hooks, then use random color. This will be the name of our library. We want a minimal installation as always, so set it to true. And finally, we don't want any kind of component, so set component set to false. Great, let's run it. we don't want any bundler, and this can be left as provided. Awesome. So let's see what is happened. So under the hooks folder, we have this useRandomColor, which internally has this index.ts. Okay, so here we are going to define our hook, a new file. Let's name it useRandomColor.tsx, and we are going to import const useRandomColor will be a function. So basically, we are gonna save the generated random color inside a useState. So let's define random color here and set random color, and let's use useState here. So here we cannot say this will be a string because we don't actually know if this, like the response that we get back from the APIs, can be a string or something else. So what we can do is to define an inline type named color, which is going to use the random color API response. And from here, we are going to get the property color. So now this color, you can see that is inferred as a string because you know that from the random color API, this is declared as a type string. So here, what we can do is use color instead. And the initial value will be an empty string. Awesome. So now we have to fetch this random color from the API. So what I'm going to do is to define a function called fetch random color. It will be an async function. And so here we need to use the fetch API. We are gonna pass it here the base URL of that server. So it should be http://localhost 3333. And now I think we can use API, random color API route, which are going to take from here under the API interfaces. We can see how it's important to have code sharing throughout this library that we already defined. Okay, so here we are gonna get the response, so res. Then what we are going to do is to extract this data by calling res.json. And actually, this needs to be awaited. Here, we can also infer this response as random color API response, because we know that the response from this API route will be always type right here. So now we can just return this data. And yeah, so that's it for our fetch random color. And now we miss the final part where inside a use effect, we are going to call this function. So here we are going to call fetch random color, and then we'll use the then operator. Here we are gonna get back the data, and we are going to set the random color to data.color. So now you can see that here the data is correctly inferred as the random color API response thanks to our Typescript support that we have set up. And finally, we can return random color here. Great, so this will be our simple useRandomColor hook that is going to fetch from our Node.js server that we set up previously. And now we can use this hook inside one of our two React applications. So now that we have our hook defined, we have to export it. So inside the index.ts, I'm going to export everything from /useRandomColor. And then we can start using this hook inside one of our function, for example, app1. Let's open up app.tsx. And here we can just say const color, and let's call useRandomColor. And you can see how simple it is to just call the hook that will make everything for us. This color will be correctly inferred as a string. And what we can actually do is define a span with the name of the random color generated. And we can also specify a style where we set the color property. So this will render basically a span with the name of the color rendered with the random color generated. Yeah, that is pretty fun to have it. So I guess that we have to restart our app1. Okay, it should work. So this is our app2. Okay, so you can see that here we have our green automatically generated. If I hit refresh, it's red. Okay, maybe we can make it a little bit bigger. So font size set to, I don't know, 32 pixels, something like that. And you can see that it's working. So if I hit refresh, we get green text, red, green. Let's say if we can get blue, there you have it. Here we have our blue text. Awesome, but the point is that it's super simple to have this kind of workflow based on TypeScript, everything inside a single repository. So everything works just fine and is super scalable and maintainable. For example, let's say that one day I want to go under my API interfaces random API and changing the API route to be API random, I don't know, color. I hit save and everything keeps working. If I open the network tab here, let me close this. Let me just select the fetch HR. You can see that the request tool is already updated correctly because everything rely on this shared library. And also, if we go back here and we run an X graph, show all the project, you can see how our application has evolved over time. So we have app 1 that is using our UI timer component, but now is using also our useRandomColor hook. And this useRandomColor hook is based on the random API interface, which is then used by the random API application. So you can see how our code base is evolving and everything is still maintainable and very simple to understand, but most important to work on. So I think that this is the real powerful of NX. And yeah, I really encourage you to try it out. If you're working for, I don't know, a company or you're part of a large team, you can start using NX for managing your code base and to have this great dev experience throughout the development. So I guess that's it for our video today. I will leave you in the description the GitHub repo for this project. And also there is a link to my Discord server. I encourage you to reach me out there because I generally use that server for communicating with you guys. So if you want to ask me a question or something else, let's join Discord and ping me there. And as always, if you like the video and you find it useful, leave a thumbs up, subscribe to the channel if you haven't already, and as always, we will catch to the next video.